Hey everybody, this is Mrs. Ellsworth, and we're going to be talking about percent composition. If you remember right, the last time we spoke, we spoke about a compound like strontium chloride, okay, and that there is one strontium, so we figured that out, and then two chlorines. Okay, so once we go and calculate the two chlorines and the one strontium, then we can figure out what the total is of both of these. This is the molar mass right here. Okay, and so again, a percent again is part divided by whole, and then times 100, and then you get the percents. So when you have a problem like this, I would like it if you would go and make your percents go out to the nearest hundredth. But let's go ahead and review. What did we do? So you take the amount of mass for one strontium divided by the whole amount, the total, okay, and then you get your value and you move your decimal over twice by multiplying it by 100, and then you've got 55.27%. Same exact thing here with the two chlorines. Add up their total, okay, and divide them by the whole amount here of all of this, the strontium chloride, the total molar mass of it, and then get 0.44, and then you go and you move your decimal over twice by multiplying it by 100, and you get 44.73. And then I like to double check my work by adding them up and getting 100%. Okay, so then I asked you to go and come up with the percent composition of glucose. So let's go ahead and check to see how well you did. Now we've got one carbon. Let me get a pen here. We've got one carbon. We've got carbon, we've got 6 of them. So we'll take carbon, which is 12.0107, and we're going to multiply that one by 6. Okay, and we've got hydrogen, 0794, and we're going to multiply that one times 12. Okay, and we've also got oxygen, and oxygen has got 6 of those also. So it's got 15.9994, and we're going to multiply that by the 6 again. 6, 12, 6, 6, 12, 6. That looks great. That looks great. Okay, so take a moment here and calculate those and come right back. Okay, here we go. Look at that. I took carbon's value and I multiplied by 6, and I got 72.0642. I took hydrogen's value and I multiplied by 12, and I got 12.09528. And oxygen times 6 got 95.9962. So we need to go and add these all up to come up with the molar mass for the total, and I get 180.15588. Okay, so that's the molar mass of this whole thing in grams. Okay, so again, part divide by whole, so we're going to divide each one by 180.15588. Okay, so go ahead and figure out what those values are. So go ahead and pause it. And don't forget to multiply by 100 and to carry out your answers to the nearest hundredth. Okay, so pause it right here and check back as soon as you're ready. Okay, here we go. And so we get 40%, 6.71%, and 53.29%. By the way, those do add up to a perfect 100%. I love percents because you can always check your work. Okay, so let's look at one that's a little bit different than this, where it's just not a formula, where they give you some actual grams of different things. Okay, so we have a sample, analysis of a sample that indicates that it's got 1.4 grams of potassium. Okay, it's got 0.7 grams of chromium and 0.86 grams of oxygen. What is the percent composition? Well, let's go ahead and write this out. We've got K equaling 1.04, okay, and we've got chromium with 0.70, and we've got oxygen with 0.86 grams. Okay, so do you remember that what percent really is? It's part divided by whole. Well, we got to figure out what the total amount here is. And it's not molecular mass this time. It's just adding up all the parts to get the whole. So take a moment here and write this down and catch up and figure out what that total amount is. Okay, so you get 2.60 grams, and that's great. So remember, it's part divided by whole. So we've got to divide each one of these by 2.60. 2.6. Gee, that's terrible looking. Okay, and so let's go ahead and figure out what each one of our ratios are here so that we can get a value here and then figure out and move our decimal over twice to get a percent. So take a moment, press pause, and catch up with me. Do those calculations and then let's look at our percents. Okay, so let's go ahead and look at this. Here are my values. I still need to multiply them by 100 because remember you move your decimal over twice for percents. Okay, so when we look at this, I didn't have this one rounded up good enough. Sorry about that. So when we look at this, so this is going to change to 40%. But 40% has got 1 sig fig. So make sure you put your period right here. Okay, because we've got 2 sig figs in this one and 2 sig figs, and we got 3. So we definitely have to go to 2 sig figs in this answer here. So make sure that you do that. So we've got 27% here. Move our decimal over twice. We've got 27%. Okay, and we've got 33%. And that looks lovely. I can tell that that adds up to 100%. Okay, what about a what if here? What if you would have gotten some value over here that would have been like a 0.0325, okay? And then you had to change it to a percent, so you move your decimal over twice, okay? You would still have to have not just 3% here like you're thinking that it would be, because you're thinking that, oh, I'll have all the same values here. You'd have to have 3.3% because you have to have 2 sig figs for each one of these, okay? So that was kind of a crazy what if for these numbers here, but you get the idea that you've got to have 2 sig figs for each one of these. Okay, well that is it. See you later. This is Mrs. Ellsworth, over and out.